Okay, so the third example that we did on Monday was problem 17 from homework 2. And so this one, we're looking at a 40-acre Christmas tree plantation that produces $2,500 of net revenue per acre at the end of every 8-year rotation, right? So we're going to plant our Christmas trees, we wait 8 years, we harvest them, we sell them, and we start another rotation of growing our Christmas trees for 8 years. We're going to use a 10% interest rate, and we want to know the present value of 5 rotations. Okay, so this time instead of going straight to the our sheet, I'll just do the timeline. So, right, we start here. We have 8 years into the future. We have 2,500. At 16 years, we have another 2,500. At 24 years, we have another 2,500, right? That's our third rotation. 32, we have 2,500, and then our final one at 40, 2,500. So this is an ending lease, so it might be that you don't own the property, but you need to know what it would be if you had a 40-year lease. What would be the most you'd be willing to pay for that? So with that timeline laid out, let's go look at our sheet. So we have these values. Is it single? No, it's not a payment at one time. We've got 5 of them. Does it happen every year? Again, no. Now we're happening every 8 years. So we're down here. So payment every n years. Does it go on forever? No, it's only 5 of these things. So it's going to end in t years. And then next thing we want to know, is it the future value we want or the present value? And in this case, we want to know what is the present value of 5 rotations. So we know we're doing present value. So what I picked here is our ugliest equation that we have, which is the present value of a terminating periodic payment. Okay, so that's what our equation looks like. Now we can write that in. So it's going to be VO equals A times 1 plus I to the T minus 1, all of that over 1 plus I to the N minus 1 times 1 plus I to the T. Okay, you may want to have brackets out here again so you know that you get all of that on the bottom. You don't want it sneaking up the top. That's the equation we're going to use. Now, what are the known values that are in that equation? A, right? What is this periodic terminal, or this payment that we're getting? It's 2,500. Okay, we've got an I in here. We know our interest rate is 10%. Okay, we've got a T and an N. Those are the two things we have. So the N, when you look down at the bottom, right, that's the number of years in between payments, right? The number of years between the payments, and the T is the total length of that time horizon. So in our case, that N is going to be 8. We get it every 8 years, and the T is 40 years total, right? All the way out here. So we've got all of our known values, and we're just going to kind of plug and chug. So we've got VO equals 2,500 times 1.1 to the 40 minus 1 over 1.1 to the 8 minus 1 times 1.1 to the 40. Right? And I can bracket that there again if I want. I need to make sure everything is done in the correct order. So what does that give me? That gives me a VO that is equal to 2,137.80, but that is per acre. Okay, so 2,100, we have 40 acres as well. So our VO for the 40 acres is going to equal the 40 times the per acre value, which is going to give us then 85,511.95. That's what those 5 rotations of Christmas trees where you're selling them every 8 years would be. So if you're negotiating with someone on a contract for managing this farm or this area for 40 years, right? You don't want to go higher than $85,511. So if he's asking or she's asking $90,000 for the right to use this land for 40 years, you don't accept that. You will lose money at 10%, or you will not make 10%. If he's asking $80,000, that's a good deal, right? So you know that you can make 85 at 10%, and so you take it. So I hope that helps with number 17. This is a good one to play with your Excel kind of knowledge. You make sure that you're bracketing things correctly so that you come out with this correct answer. You'll get the key, which will have the Excel formulations that I have for each of these. So you'll get to watch that at the end. But right, it's a good one to try to figure out how you're doing getting these more complicated equations into the cells.